U-functs are vectorized functions that are used to perform element-wise operations on Numpy arrays. Numpy U-functs is short for universal functions for speed and simplicity. And then we have our common U-functs here, or standard arithmetic operations, add, subtract, and the likes. We have trigonometric operations like sine, exponential, and the likes. There are two types of U-functs. There is the unary U-functs, and then there is the binary U-functs. For unary U-functs, those are U-functs that take a single input. And then for binary U-functs, they take two inputs, usually two arrays, and then they generate another array. So we're going to be looking at these in this tutorial. We also have some U-functs methods there, like reduce, accumulate, alter, like that. So let's get into our IPython and play with some examples here. We're going to start with unary U-functs. I would say those are U-functs that take a single input. Okay, so let's have I don't know, let's have x equals np dot array, and then let's have a Python list here. We can have 1, 2, 3, 4, like that. Okay, I've done it again. I didn't import Numpy. Okay, sorry about that, guys. Then we do x equals np dot array, like that. Okay, and then we can do np dot square root. So the square root is going to look for the square root of our array elements. Okay, so we get that. We can also do np dot square, and then we can pass x here. So this squares the elements in array x. Okay, what else can we do? We can also do np dot exponential. So this takes what is it called? Euler's number. I think 2.718 approximately, if I'm not mistaken. So np dot exponential, we pass x here. Okay, so this calculates the exponentials of each of the values that we have here. We can try to do some logarithms as well. Let's see, for the logarithms, let's stick with this and let's try for logarithms. We can do for natural logarithm, we can do np dot log. So these are all unary U-functs, pass x here. So logarithm to this natural logarithm, so that's e raised to power x, I think, and then e takes the Euler's number again for here. So if we do this, we get the natural logarithms of each of the values here. And then we can also do for logarithm to base 10, then we pass x, so this gives us this. We can also do for logarithm to base 2, then we pass x here. Okay, so that works. What else can we do? Let's do for some trigonometric functions or trigonometric operations and hyperbolic unary U-functs. To do that, let's create theta, and then we can do np dot line space. We start from 0. We're going on to 3.0 np dot pi. So, okay, so from 0 to pi, let's generate 5 items. And then we can do np.sign. Then here we can pass data. This is going to find the sign of each of the, or before we get into that, let me show you what we have inside data. So we have 5 items from 0 to 3.14 blah blah pi. Okay, then we can do np.sign. Then we can pass data here. Let's find the sign of what we have. np.cos as well, cosine data. Okay, you can do np.tan. Then we can pass data here. So we got the value. Okay, we can do for some inverse trigonometric as well. So we can do we had, okay, let's do y equals np.array. Okay, let's do this. Let's use this for our inverse trigonometric. So we can do np.arcsine and pass y here. Okay, then we can also do np.arccosine y, on and on like that. Let's not waste each other's time, so you guys can practice this on your hand like that. We could also have I don't know, if we had array and then we do np.array and then here we do okay, list. We do -3, -2, -1, 0, 1, 2. Okay, then we can do np.absolute value, absolute, and pass array here. So this returns absolute values. We can also do np.absolute, I think. So we pass yeah, array still works. Okay, that's that. Let's go to binary ufuncs. Our binary ufuncs take 2 inputs. So let's try and do that. For instance, we could have let's have x equals np.arrange. No, what did we have as x before now? Okay, so this is x. Then we can do np.add. So we pass our array x and then we pass a scalar. Let's say we pass a scalar 8. Okay, so this had 8. So now we are in binary ufuncs now. 2 inputs. We can also do, what do we have in y? 3 items, 4. Oh, this is not going to work. So let's do y, this, and then let's do 2 like that. Okay, so that we can do np.multiply and then we can pass x and y. So this multiplies both of our arrays x and y. What if we did np.greater and then here we pass x, y. Okay, so it's saying all the elements in x are greater than y, which is true. What else do we have? We could also do np.maximum and then we can pass x, y like this. Okay, so this gets us the maximum values in x and y array. We can also try to do for instance, just as we did for maximum, we could do for minimum, but I'm not going to do that. We could do a equals np.array I'm going to pass 3 values here, 2, 5, 7. Then I'm going to b equals np.array 3 values as well, we're gonna do 1, I don't know, 4, 8, like that. Then if I do np dot hypotenuse, so hypot, then I can pass a, b. So this is gonna form some kind of it's gonna create some kind of right angle triangle in memory, then assign this element to its size, and then gets us the hypotenuse values. So this is what we get. Okay. Let's not waste each other's time on this. Let's look at some advanced U-funcs. So I can do, for instance, I can do P equals np dot arrange, and I pass 5 here. Then I can do Q equals np dot empty 5 here. Okay. And then I can do np dot multiply. Okay, so what do we want to multiply? We want to multiply p, or the elements in p, let's say by 10, and then we want to pass the output inside q, like that. Remember, q is empty. Good. So then if I do q, okay, so now I have q populated. Okay. We can also do something like if we did y equals np dot zeros. So let's say we pass 10 zeros here. Okay. And then what if we did np dot power? Okay, power. So raised to power what? Say we want to do raised to power 2. Okay. And then which array do we want to pass here? Let's do array p, which was, yeah, that's what we had the other time. And then we can pass our outputs here, which is equals to this output y, which is np dot zeros. Then we can do y, and then let's slice, and then 2. So which makes sense because this is 10, and then we're passing array p, which is 5 items. So we're stepping by 2 so that it fits with our dimension. Okay. So if, fingers crossed, if I press enter, good. So this works. All right. I'm not going to drag this too long. Good. So what else can we do? Let's do some aggregates. If we did, let's do x equals np dot arrange, and then here if we do, so we do 1 to 6. I think that's what we set for. So x, okay, 1 to 5. Good. Then if we do np dot add dot reduce, and then we pass x here. Yeah. Remember we went from add. Now we do add dot reduce. So if we call the reduce on the add U-func, so what happens is we return the sum of all the elements in the array. Remember when we use add, well, we sort of like, we had a 2 inputs, 2 arrays. Now we're doing some advanced U-funcs for aggregates here. So we have an array x, and then we're doing np.add.reduce. So this has all the elements that we have here. So, and then it returns the sum of all the elements in the array. So if we do enter, okay, so this returns the sum of all the elements we have in the array. integer 64. That's the type. I hope that is correct. All right. Just as we did for addition, we can also do for multiply. So that multiplies all the elements we have in our array. So np.multiply dot reduce, and then we pass x here. Okay, so we get 120 for that. We can also do for, let's say we want to store all the intermediate results of our computation. So we can do np.add.accumulate. So we can do np.add.accumulate, accumulate, and then we pass x here. So so this is what we get. I hope you can understand what is going on here, because this was x, and now this is np.add.accumulate x. This is what we have now. So 1 plus 2, 3. 1 plus 2 plus 3, 6. 1 plus 2 plus 3 plus 4, 10. 1 plus 2 plus 3 plus 4 plus 5, 15. So that's what this is doing here. Let's try one more outer product. We did outer product when we did a tutorial on broadcasting. So let's see how we can use some advanced ufuncs to achieve outer. So if we did, we had x, this is x. If we did np.multiply dot outer, okay, remember outer is going to take 2 arguments, 2 inputs. So we use outer to create a multiplication table, right? So if we do x and then we do x, so we're using this 1 2 3 4 5, this x. So we pass x. Let's see what we get. Good. So this is working as expected. Okay. There are more. So guys, you can scour the internet and then check for more ufuncs. More vectorized functions, and then see how it goes on your own hand. So I'm just going to stop here, and then I'll see you guys the next tutorial. Thanks for watching.